our president-elect to do the official welcome and introduction. Are you on P. Newton? No? Did anyone see P. Newton on online yet?
He sent in his apologies.
Okay. So let us go ahead then. We'll take the opportunity at this time to ask those Kiwanians online to introduce their guests, and at this time, we'll start with those that are outside of Jamaica. Those Kiwanians outside of Jamaica that would like to bring greetings at this time.
Good evening. The name is Dora Henry, President Dora from the beautiful island of St. Lucia, Kiwanis Club of Castries.
Okay. Okay. Thank you for coming. Do you have any guests with you tonight? Any of your other members are on with you?
My treasurer, Vincentia, should be on. I saw her on earlier, so she should be on as well.
Okay. Thank you. Any others from outside of Jamaica? Kiwanian outside Jamaica? If not, we'll move to inside of Jamaica. We'll go to Division 25. Those Kiwanians in Division 25 that would like to bring greetings at this time.
Good evening, President.
Good evening.
Kiwanis Club of Hopewell in Hanover is pleased to be with you this evening.
Okay.
We are well equipped for this trip tonight, and we won't be left behind. So we bring you greetings. There are 4 of us here this evening, and I am DLG Joe. Hi, DLG Willie.
Hi, Mark Joe.
Yes,
How are you doing?
I'm well, thanks.
Good.
Thank you for attending.
Thank you.
Any other from Division 25? Then, if not, we'll move to Division 24. Kiwanians from Division 24 that would like to bring greetings at this time. Well, we'll move on then. 23, we start with 23 East.
Good night, everyone.
Good night, a very good night to you.
Yes, I am IPP Audrey from the Kiwanis Club of Papine. I'm the only person here at the moment. I'm awaiting the arrival of others, and I wish you a wonderful meeting. Thank you.
And I'm sure you'll enjoy it. All right, Division 23 East.
Good night, Prez. Oh, sorry.
Go ahead.
Yeah. Yes.
Hi, good evening. From 23 East Professional St. Andrew Online. I'm Director Rachel, and with me is IPP President Courtney.
Yes. Thank you for coming, Director Rachel.
Yes, good evening. I bring you one things from the Kiwanis Club of New Kingston. I'm President Audrey. I believe we only have 3 of us online right now. We want to take the journey with you. We have LGE Sandra and co-chair Janet, but I know that others will be joining.
I'm sure others will join as the meeting progresses. Okay, thank you for coming. Division 23 East, any other? Division 23 East. If not, we'll move to.
Hello, good night. I'm a part of Division 23, not sure exactly if it is East. My name is Akeem Edwards. I'm a prospect here from the Kiwanis Young Professional St. Andrew. And Khadija Daly and Marco Daly are here with me as well. Three of us as prospects representing the club.
Well, good. Thank you for
23
coming. I would like-
Central. 23 Central.
Yes, but nonetheless.
Thank
Yes, thank you for coming. Any others from 23 West? 23 West? If not, we move to our own division, 23 Central. Those Kiwanians that would like to bring greetings from 23 Central. I'm sure they saw quite a bit online earlier.
Greetings, President.
Greetings.
Greetings from the Kiwanis Club of North St. Andrew, flying solo at the moment. Other members are about to log on in a few minutes. I'm distinguished President Mark, and I'm also here in the capacity of a good friend, schoolmate, Vaz and Calabar of your speaker. So I'm here in solidarity and looking forward to the presentation.
We are all looking forward to the presentation, and I'm sure we are going to be excited by it. 23 Central, any other from 23 Central? Yes. 23 Central. If not, we'll move on. What about our SLPs? SLP online that would like to bring greetings at this time?
President, good evening. I'm FA Audit, bringing you warm greetings from your
Please, I'm asking everyone.
Your very favorite VP, past VP. So I know I have there joining with us this evening.
DB Alden, please mute your microphone.
Yes.
I was saying I'm bringing greetings.
She was on first.
Okay.
Yes.
Continue.
Continue now, yes.
All right, that's it basically. I was just saying things from your children.
Yes.
Afternoon.
Okay. Thank you.
I know you miss your very favorite.
Yes.
Danielle, past VP Danielle. She is actually preparing for some studies tonight, but we do.
Okay, thank you. And thank you for attending. Any other?
Good evening, President Junior. I think
Yes,
you passed 23 Central, but I just want to ask for your permission to introduce my club, 23 Central Surrey Online. And at this time, we have a delegation of 3 members, myself, LGE Desmond, and Treasurer Melvin.
Okay, thank you for coming, and I hope you have always been with us. And I hope that some other members from your team will be coming on later.
Yes, I certainly hope so myself. Thank you so much. Bye-bye.
All right, thank you. Any others that would like to bring greetings at this time?
Good night, everyone. Am I being heard?
Yes, we are hearing you.
Yes, you are, Malik.
All right, good. My name is President Malik Harris. I'm bringing greetings from the St. George's College Key Club. At the moment, we have 6 online, and I'm expecting more. Quick shout out to DLG William Reason for extending the invite once more.
Okay, and thank you all for coming. You know, you're always welcome to our meetings, right? Any others? Any other that would like to bring greeting at this point in time?
President Junior, we also have members of the Kingston College Key Club as well as St. Louis.
Okay. Thank you for coming. Thank you for coming. Thank you all for coming. All right, we'll close this session now, and we will continue our meeting. We will the recognition of no, we'll move now to the apologies for absence. P.E. Newton apologize for his absence. Are you coming late, DLG?
Yes, he has an engagement currently.
Okay. So are there any other apologies for absence?
Yes, apologies for absence from Treasurer Orville. No.
Yeah. Okay. Any others? Any other apologies for absence? If not, I'm going to move into the recognition of birthdays and anniversary. VP Stephen. Is he on?
Yeah, I'm on, President.
Yes. How are you?
I'm fine, thanks. Keeping well.
Good.
All right. As is customary in our club, we'd like to acknowledge birthdays of our Kiwanians and their spouses. So I'll just take a moment to share with the meeting some of our Kiwanians who have special days coming up this week. First of all, DLGE Stan Donwell. Today is actually his birthday. I notice he's probably out celebrating. So best wishes to DLG Stan Donwell on his day. And again, a plug for the Kiwanis annual charity ball, which is coming up. DLG Stan is very active member of that committee, and he's going to encourage, if he was here, he would encourage everybody to make sure that they buy their tickets and support this venture. On November 24th, we have quite a few Kiwanians who celebrate their birthdays. Kiwanian Lloyd Forbes, PD Reverend Strottrell Lowe, and our own PE Newton Ramdale all celebrate collectively their birthday on the 24th. So special greetings to them when that comes along. On November 26th, Marjorie, the wife of PD Trevor Ford, celebrates her birthday. So best wishes to her at that time. On the 28th of November, we have a Kiwanian Colin Barnett, as well as Colleen, who is the wife of Kiwanian Garwin White. They celebrate their birthday on the 28th. And in terms of anniversaries, and I notice he's here, Director Warren McDonald and his wife Joan will be celebrating their birthday on the 27th. So best wishes to them on that special occasion when it comes along. As is customary, I'll also extend it to any of our guests. If there's anybody celebrating a birthday, we'll be happy to hear it so that we can also share in that event with them. Is there anybody on line or in the meeting who has a special birthday anytime between now and next week, Tuesday? Oh, I see DLG Desmond Batchelor, his wife's birthday is on November 24th. So that should have been on the list. Best of wishes to her, DLG Desmond. Is there anybody else?
Thank you. Thank you.
Yes, yes. If not, President, back to you, and you can continue with the program.
Thank you, VP. And those are the birthdays and the anniversaries so far. We'll move now to Kiwanis Education and our LGE Desmond.
Thank you.
LGE Desmond.
Thank you, President Paul. Can you hear me?
Yes, we are hearing you loud and clear.
Okay, good evening, everyone. My topic is responsibilities of the Lieutenant Governor and sponsoring clubs to a new Kiwanis Club. And my source is Kiwanis International Policy and Procedures. Lieutenant Governor shall assist in the formation of new clubs and shall have the responsibility to determine that the new club has and maintains the minimum number of active members at the dates of organization, chartering, and throughout the administrative year. The Lieutenant Governor shall designate which club or clubs shall be recognized as the sponsor or sponsors of a new club. The sponsoring clubs, the Lieutenant Governor at the time of the organization and any succeeding Lieutenant Governor shall assist the new club for at least 1 year after its organization and be responsible for A, club meeting programs during the first 13 weeks, B, continued membership recruitment efforts and maintenance of active membership of not less than the number of members required to organize a club. C, assistance in planning for and attendance at the club charter ceremony. And finally, D, development of proper club administrative procedures and programs of community service. And that's it for Kiwanis Education President Junior.
Good, thank you.
You're welcome.
Good. It's time for our guest speaker, but just before we'll be having our introduction and for our guest speaker, the professor. And who is better to do this than our own DP Stewart? DP?
Yes. Yes, I'm just checking if I'm being heard. Yes, I'm on.
You are on, and we are hearing.
Okay.
I was just saying who is better to do it than.
Okay. Okay, fellow Kiwanians and guests, tonight we have a very special guest. He's Dr. John-Paul Clarke, who is a professor of aerospace engineering and engineering mechanics at the University of Texas at Austin, and holds the Ernest Cockrell Memorial Chair in Engineering. Earlier this year, he was appointed to serve as a member of the National Aeronautics and Space Administration, that's NASA for short, Advisory Council. The NAC provides counsel to NASA leaders and advice to the agency's priorities and programs. Dr. John-Paul Clarke attended Vass Preparatory School and Calabar High School in Jamaica. May I add, so did I, both Vass and Calabar. And emphasized the environment of excellence in which he was raised. He's the son of the Reverend Canon Dr. Jervis Clarke, a Calabar old boy, and Dr. Joan Bingham Clarke, a pediatrician. He earned his bachelor's degree in 1991, his master's in 1992, and his doctorate in 1997 in aeronautics and astronautics, all from the Massachusetts Institute of Technology, that's MIT. Dr. Clarke notes that he has been interested in aviation all of his life and remembers the year the flights he took on vacation with his family, adding that he was just a year old when he took his first flight from Kingston, Jamaica to New York. He said that his first career interest was in being a pilot, but then realized that being an aerospace engineer would be more fun because he could design aircraft. Before taking the position at University of Texas, Austin, he was a member of the faculty of Georgia Tech and MIT. John-Paul has not spent all his working life in academia, as he was Vice President of Strategic Technologies at United Technologies Corporation, now known as Raytheon, and a researcher at Boeing, as well as at the NASA Jet Propulsion Laboratory in Southern California. He is a co-founder of several companies, including the recent Universal Hydrogen, a firm that develops carbon-free solutions for aviation, and at which he is the Chief Technology Officer. He's an expert in aircraft trajectory prediction and optimization, as it relates to procedures that lower the environmental impact of aviation. His aerospace research has brought him numerous honors, and in fact, his contributions to aerospace extend well beyond his research. Recent awards include being named as the Aviation Week's New Pioneers List, Advanced Air Mobility Leaders in 2021, and he was also elected a Fellow of the Royal Aeronautical Society in 2021. In his spare time, Dr. Clarke is a track and field official and serves on the World Athletics International Technical Officials Panel for North America, Central America, and the Caribbean. John-Paul is actually coming to us this evening from the Cayman Islands, which is where his wife is from. And I read where he sings in a small choir when he's in the Cayman Islands. I hope that's a fact.
It is a fact indeed.
Okay. A man of many parts. Fellow Kiwanians and guests.
No, only one part, bass.
Oh, oh, bass. Okay, that's good. Well, I meant many parts outside of the singing. Fellow Kiwanians and guests, help me welcome Professor John-Paul Clarke. Over to you, John-Paul.
Thank you. I'm going to switch here.
Yeah, I gave you sharing privileges.
Everybody can see that?
Yes.
All right, excellent. So I was remarking to my son, the one on this one here, you can see.
Okay.
Just a few moments ago before we started that I always have a difficult time talking about myself. So I'm going to see how this works out. And after that very robust and an extensive introduction, I feel like I don't need to say anymore. But anyway, I'm going to talk about my life's journey a bit, and hopefully end with a few lessons. And my dad, who you heard was a minister, a priest rather, so always told me to say 3 things because a good sermon is 3 points. But I'm going to break that rule tonight and just make 4 points. But I will cheat and say, I will say that the last one, what did I learn, will have 3 points. So I'll add the extra one, but it will be just 3 points. It's really a pleasure to be with you. I wish I could be there in person, but you know what? Zoom is a wonderful thing, and I'm glad that we were able to arrange this by this medium. So what I want to do this evening was just basically talk a little bit of what I do. And then I'm going to, because, you know, oftentimes you think somebody's an aerospace engineer, you kind of know what we do, but you don't really know. So I'm going to tell you about the stuff that I do, which is somewhat wide and varied, but it's all because I like to have fun. And as you'll see, there's a theme around that. And how do I do it? I'll talk a little bit about the skill sets that I think are important to solving these kind of problems. Talk a little bit of how I get there, which will rehash a little bit about my history. But I'll talk about the things that I've learned along the way. And then I will summarize what did I learn, the 3 things that I've learned in my life so far, which I hope will be instructive. And I will do my best to come in the half an hour time that allotment that I've been given. So let's see how it goes. All right, so what do I do? Technically, I'm a rocket scientist. I like saying that because, to be honest, when you're having a discussion and somebody say, who do you think you are? You're a rocket scientist? Like, why, yes, I am. So I actually do love saying that. As you can see here, you know, there's been a lot of different rockets and there are different sizes and really cool stuff. And you know, but what I really do, and this is true for engineers in general, but it's true for any profession, is I solve interesting problems, or at least I hope that you're working on interesting problems. You solve problems. Some of them may not be interesting, but for me, I focus on solving interesting problems. And that's the one luxury that I have as an academic, is that I can do whatever I want as long as I can convince somebody to give me the money to do it. And so that's the reason I've stayed in academia, quite honestly. Well, not only, you get to do fun, work with fun, cool people too. So, you know, you talk about NASA and you think about, you know, all the stuff you do in space, but the first A in NASA is aeronautics. So, and I will talk about it. I really like airplanes. That's really my first love, but I've done some stuff in space, you know, and as an undergrad, we worked on a modular small satellite system for Earth observation, which actually, this is my senior design course. And our project actually led NASA to make a certain decision about the architecture for EOS, the Earth observing satellite system. I worked on my master's thesis at JPL on a radio astronomy receiver. So space observation actually sits at the observatory in Mauna Kea in Hawaii. And I actually designed the tuner for that system as my master's thesis. I did some early research when I was a faculty member at MIT on using plasma within launch vehicle fairings. You know, the fairing is the thing that covers the payload in the top of the rocket. And we actually use plasma as a way to reduce the vibrations. The big problem with plasma, that you got to carry a big power source along with the plane. So it was nice for the research project, a little bit impractical in real life. We've done, my first PhD student did telerobotics for space station, basically how to remotely control robots for the space station. And then I also had a student which I advised looking at optimal trajectory for asteroid exploration, which is what's the optimal path for you to send us a probe to go and visit a sequence of asteroids that are all moving around their local planet, and the planets are moving around their local center of their galaxies. So I've done space stuff, but to be brutally honest, I really love airplanes. And that started in Jamaica. My parents like to drag me all over the world on travel, and I just love airplanes. And what do I do? Well, the thing that I'm probably most well known for is what you see here. We've done a lot of research over the years and designed an arrival procedures where you basically put the airplane to idle at top of descent, at cruise, and you descend that idle pretty much all the way down to runway, which means that you can do it at higher speed, you can reduce fuel burn, you can reduce noise, you can reduce emissions. And that contrasts to the way we normally do things, which is to have step downs with level segments where you burn more fuel. So you can actually save a significant amount of fuel. And this started as research. On the side you see the left, lots of math. We built a simulation of how airplanes behave in wind fields with uncertainty. And that ended up in the real world. So every time you land in LA, Los Angeles, and you're coming from the east, that arrival procedure was designed with the technology and the tools that I developed, my students and I developed. And we've actually seen significant savings, 41 million metric tons of reduction in CO2 every year due to this procedure. So it's kind of cool, fun to do. And the key here is that, getting the right models in place is something that is the lesson that I've learned from this project, which is, modeling the thing the right way in order to influence your decision is probably the big lesson here. The other things that I do is, this was a project that I did many years ago for the FAA and around New York, which I came up with a planned remodeling of the entire airspace around New York City. And basically on the left, you'll see what the air routes look like. So those of you who fly to New York, don't think about how chaotic that looks, but it is kind of that chaotic. But air traffic controllers have it handled. On the right is something that looks very much like a very structured network circuit design where the paths are all decoupled and the aircraft can basically take off and climb unrestricted and descend unrestricted without worrying about crossing traffic, etc. So this is something else that I do and have done in many other areas. The other thing that I've done is design new airports. So this one looks like a Star Wars X-Wing fighter. For those of you who are Star Wars fans, I'm more of a Star Trek person myself. And basically this airport was designed to basically deconflict all the traffic. So the arrivals, for example, can land on this runway, go down here and slow down and then come back to the terminal area. And then they can continue and go back here and take off on the outboard runways. And if you're going the opposite direction, they could land on the outboard, come in, and then take off on the inboard runways. What do you notice? You notice that all the traffic flows are one-way traffic flows. They're either merging and diverging, merging and diverging. And so this is something that was instructive based on how we do with roads. When we have a two-lane road that we have lots of congestion, what we do, we turn them into one-way roads. So this was the inspiration for this particular project. Another project that we've worked on over the years is optimizing the assignment of flights to gate. For those of you who've connected on major international airports, sometimes you arrive at one gate and then you have to walk all the way to the other side of the airport. There's also true that there's congestion in the concourse. So this is like Atlanta. If a flight comes in here on this end, it may have to go all the way to park here and then turn back and go all the way to come out this way. So we actually developed an algorithm that looked at the passenger flows inside the terminals, the airplane flows on the ramp area, and say, let's minimize overall the amount of time and effort it requires to connect from one flight to the next. From the time you arrive at the corner of this ramp to the time you leave at whichever ramp you go out. And so what you can see here is that we were able to achieve a significant reduction in passenger time as well as total taxi time simultaneously by coming up with a balanced approach to this problem. On the airline side, I've done rescheduling of airline flight schedules, so robust maintenance routing. So one of the things that this is an interesting problem that I had to solve, which is how do you think about an airport? You know, typically we think about an airport as being stationary and the flights coming in and out of an airport, right? And all the math around how we solve airline scheduling was focused on that viewpoint. We flipped it on its head and we said, let's think about airports as some things that come in and out of an airline schedule. And if you think about it that way, you realize that some airports are like problematic friends and some airports are like helpful friends. And you have different strategies to deal with problematic friends. People might get together and say, okay, you take this friend today, I'll take the friend tomorrow, this third person take the friend the next day, and we spread the pain around. Or we say, you are the draw the short straw, and you basically deal with this friend for the entire week, right? So with that viewpoint, we were able to design, put together a math algorithm that actually determines what is the optimum sequence of airports that flight should go through to minimize the propagation of delay. Because if the first flight is delayed, then the second flight is going to have a high probability of delay and so on. And so the algorithm that we implemented, we tested it on the network for what was then Continental Airlines, and we found that we could reduce the propagation delay by about 40%, increase on-time performance by 1.6%, and reduce passenger misconnections by about 11%. And then we also continue to look at retiming of flights by adjusting times within short windows. And then we found that we could reduce the misconnections by 38% further if you did that little tweaking. And this actual work is my most cited paper. I'm probably more well known for the CDA work, the continuous descent work I talked about, but this is one of my most highly cited paper. So I hope that gives you a flavor of the things that I do. You said I'm a man of many parts, and I told you that I do whatever I want to do as long as I can find somebody to give me the money. And so I'll go on to the next thing to say, the thing that I've been doing most recently is we've designed a hydrogen-powered aircraft and a modular hydrogen distribution system. And this is born out of the mutual interest of my co-founders and I in reducing the environmental impact of aviation. And so we were at a dinner in New York. And I will add that most of my companies that I've formed always get formed at a dinner meeting. So I've stopped going to dinner meetings because my wife kills me every time I come home and said, honey, I'm starting doing something else. But so anyway, we're at dinner in New York, and we were talking about what could we do to really change the world of aviation and achieve the Paris 2050 goals. And we looked about hydrogen, and everybody has this view of hydrogen as being mostly engendered because of the Hindenburg incident back in the 30s around hydrogen as being dangerous. But if you look at it, it's actually pretty safe. In fact, safer than kerosene and jet fuel, because hydrogen doesn't pool. If you have an accident, it actually vaporizes quite quickly. But the thing that really hit home with us was the whole, how do you distribute the hydrogen? Because if you think about the system that we grew up with and have gotten accustomed to, which is, petrol and diesel distribution, there's a reason why all the gas stations are Esso and Exxon and Shell and Texaco and Rubis and all the different oil companies around the world. And the reason is they had to build out their infrastructure over decades at an exorbitant price in order to distribute their product. And so we looked at that and we said, hydrogen is going to be a real challenge to do that. So how do we jumpstart the hydrogen system, distribution system, without spending trillions and trillions of dollars. So that was the thought experiment that night. And so we said, what would happen if we could design a modular hydrogen distribution system where we could actually build storage that we could, storage for hydrogen, and so that we could transport the hydrogen, as you can see on the right, we'd fill it at some location like a hydroelectric plant or a wind farm or a solar farm that's out in the middle of nowhere, which is mostly where they are. And then move that hydrogen. And by the way, you can get electricity very, very cheap at hydroelectric plants in the middle of the night, because hydroelectric plants are really hard to spool up and spool down. And so they would rather dump the electricity in the form of heat at night than actually spool up or spool down. So you can literally get electricity at very, very cheap rates. The problem is, the current way we do it is that when electricity is produced, it actually has to be then consumed in short order, actually transmission time. So the idea here is you'd buy cheap electricity, ideally green electricity, hydrogen, hydropower, solar, and etc. And then you turn it to the hydrogen and you transport the hydrogen using the existing intermodal freight transportation system, which somebody else paid to develop. We're just going to use it. And so that's the idea. And so we have designed the storage modules. And the other thing that we wanted to do is to control our own destiny. So we actually designed a modification to the Dash 8. They have in Dash 8 300, as well as the ATR 72 and 42. So we're in the process, and fingers crossed, we will have the flight of the largest carbon-free aircraft before the end of the year. That's our target. That's what we're shooting for. And if anybody's interested, you can just Google Universal Hydrogen. Lots of cool videos about our airplane and our power plant. And we have our patent on our powertrain has been issued recently. And so you can see here what we've done is create a distribution system and created a mechanism by which we can consume it. And we're in the process now of scaling up and working through all the different things of actually moving to production. So we've started the certification process. We're going to do our first flight. We're actually doing ground tests in Toulouse, which is our second. We're based in California at Hawthorne. And then we have a second facility in Toulouse, France, where we're working on the capsules, especially the liquid capsules. So that's basically what I do. Now, the big question is, how do I do it? And I have things there. The first answer to that is I take inspiration from the world around me. So you guys remember that, I hope, that airspace around New York that I said I redesigned? That actually came to me in the morning, one morning in the shower. And my inspiration was for that was the subway map in London, which is basically, if you look on your left, you see what the subways in London really look like. On the right, you see the maps in London. And this is a very famous map that was developed in the 19th century for how to describe subways or linkages between locations in a functional way as opposed to in a geographical way. And so this was my inspiration for how to redesign the airspace system. And again, you can see on the right, it looks like a circuit, but it's not really a circuit. And that was the idea that I came up with when trying to put that airspace together. So I guess the point I'm making here is that oftentimes solutions to really complex problems come from things around us and from nature and from your experience. And so I think one of the things that I have been lucky to have had the opportunity to is to experience a lot and to actually keep track of them and actually have this freedom to actually spend time thinking about them and how to exercise them. The second thing that I use quite extensively in my work is developing the right models. So what you can see on the top, the left here is basically a map showing the distance of airplane travels as a function of time. And you can see that when you're at a metering point, i.e. you're passing a point in space, over time, uncertainty builds up because there's uncertainty in the wind, aircraft performance, etc. And so the time is going to be at a future location there's going to be some uncertainty. And so what we did was we said, how do we measure that uncertainty? when you have two aircraft following each other, because ideally for the continuous descent, you want the airplanes to go to idle. Now, for those of you who fly or are avid aviation buffs, when you put an airplane to idle, you've turned that airplane into a glider. And a glider is susceptible to all the uncertainties in the wind. And so what we had to do to figure out how far airplanes have to be apart at the top of descent to make sure that they could descend without violating the minimum separation is to actually model the wind field. And so we developed a technique for modeling the wind field where we decomposed it into a DC or a static component, a low frequency and a high frequency component. And we actually model the lead aircraft with the DC and the low frequency, and the trail aircraft with a DC, low frequency, and high frequency. And we were able to compute in a very compact time. And if anybody's interested, happy to talk about it at another time. Model for how we actually model that separation. And out of that came these curves like this at the bottom left here, which basically describe the probability that your spacing will be below a certain value, given your spacing at the top of descent. And that was the basis of this. And I was just showing you about how much we've saved. We've basically seen here that we can actually see about, 14 million tons of carbon reducing flight delays by 21%, and basically save about $1.4 billion of fuel every year in 2018, based on 2018 numbers. So not so bad in a day's work, I think. And then the last thing I was speaking threes is that how do I do it? Is to apply the right model and the right math, right? And so one of the things that as an engineer in aerospace, you tend to focus a lot on continuous math, calculus, etc. But you have to learn to apply discrete math. And so the thing that I use a lot is basically math programming, which is what people in operations research and computer science, you do a fair bit, and learn to model things as linear terms, like linear combinations. So you weight different factors with just plain constants, or actually looking at the combination of different terms, which is what you call quadratic terms and quadratic programming. For those who like SpaceX, the Falcon rockets, that they take off and they land on their tail. That's the first that has been done. And that's the first example of what we refer to as quadratic programming being used in real life. So I didn't want to go into too much detail. I probably went into too much detail already. Or how do I do it? But that's what I do. I basically, take inspiration from the real world, apply the right models, and then add to that the right math. So going back to the introduction, the kind introduction, how did I get here? Well, as you know, I was born in Jamaica and very proud of it. I went to Vast Prep, and the thing I learned at Vast Prep were the basics. I'm still using them today. Then I went to Calabar, and by the way, I had a lot of fun. That's the first thing. I went to Calabar, I learned a lot more stuff. I joined the Cadet Corps. I threw shot put and discus. I participated in student government as deputy head boy, and I had a lot of fun. Too much fun. Some of them I'm not allowed to repeat because they might incriminate me. Then I went to MIT and I learned more stuff. I threw shot put, disc, and hammer. I participated in the Caribbean Club. I interned at NASA JPL, and I had a lot of fun. I was a captain of the MIT track team as well. And I was the president of the Caribbean Club. And I did a lot, and we actually organized the first and the Northeast Regional Student Conference for Caribbean students. So it was a good time. And then I went to grad school there because I didn't learn my lesson, I guess, or they didn't learn their lesson and let me in a second time. And so I learned more stuff. I created even more advanced stuff. I coached as a grad student. In fact, I coached a national champion. I was in the Black Graduate Students Association. I interned at Boeing, and I DJ'd with my brother, who at the MIT radio station. I ran the radio station, and I had this what I call my JFK moment when I became the general manager. I made my brother, because you can appoint people. I made my brother the music director. And so the two of us really like ran the place. And then I had a lot more fun. And then I became a faculty member. And I still learning, still creating stuff, teaching some really smart students. And I said earlier, why I stay in the faculty. The second thing, apart from being able to do what you want, is to be able to work and teach really smart students. And anybody who's a faculty member, but anybody who's a manager knows that your people that you work with and who work for you make a difference. And that's one of the reasons why I stayed in academia. And I'm serving on way too many boards and committees. I spent most of my day today at Cayman Airways. I'm the chairman of the board. I'm on the NASA Advisory Council, where, as you heard, we advise the administrator. As part of my role on the council, I'm the chair of the Aeronautics Committee. So I get to oversee their programs and provide advice and write recommendations. I've also served on the U.S. Army Science Board and the FAA Research Advisory Committee. I've also served on the DOT, Transportation Statistics Council, too many things, and many National Academy boards. But I only do it because I'm having fun, right? If it's not fun, I stop. So with that said, let me close, and I think I'm on with doing well with the 30 minutes. Let me close by saying, what did I learn? In all of the stuff I've talked about, what did I learn? Well, I learned the following things. Number one, if you love something and you have the aptitude for it, do it. Now, notice I said it's a two-part thing, right? If you love something and have the aptitude for it, do it. If you love it and you don't have the aptitude, don't do it. And if you have the aptitude and you don't love it, don't do it either, right? You have to love it and have the aptitude for it, because if you have the aptitude and it's fun, it will not be like work. Just this morning, somebody asked me, what does it feel like to be doing something that you really love, doing well, and getting paid to do it? And I'm like, it's the best thing that anybody can do. So that's my first lesson. And as I said before, I really love airplanes. And this is my first airplane I've ever been on. It's for those of you who are old enough, you remember this is the Vickers VC-10, which had 4 engines on the back, 2 on each side, which is what BOAC used to fly into Kingston, Jamaica, from New York first, and then later on they used to connect to Bermuda. So this was the first flight, Kingston to New York on the VC-10. Obviously, I don't remember because I was 1 year old, but it was in my junior jet club logbook, and still there. And the thing about this airplane, it is a great example of what not to do when you're designing an airplane. First, your customers never know fully what they want. So the BOAC went to Vickers and said, we want an airplane that can fly New York to London. We want it whisper quiet in business class up front, because we don't want our business passengers to be disrupted. We want a plane that can fly to Kenya and to India and to South Africa and to the Caribbean and on our colonies, and operate on runways that are not necessarily free of foreign objects, right? So we don't want any FOD damage. And we want the airplane to have a high altitude performance. And they put a list of specifications together. And Vickers went back like good engineers and said, okay, here we have an airplane for you. This is it. It hit every one of the requirements, except the one that the customer didn't ask, which is, I don't need a gas guzzler. And so what happened in 1973 when they had the OPEC oil crisis, BOAC started retiring this airplane 1 month later because they couldn't afford to operate it. And so this airplane was inspiration for the course that Earl Merman, John Hansman, and I developed at MIT on system architecting, which is how do you elicit the get together the specifications for an engineered system based on market forces, regulatory forces, and the true needs of the customer. And so that it was my first airplane, but it also was the inspiration for a new class as well. and as well as engineering, as products. And the second thing I've learned in my life, and I hope this resonates with many, when you come to the fork in the road, choose the path with the greatest number and quality of options. And I actually lived that through my life, which was, as you know, I was born in Jamaica, but then I basically left Jamaica in '87 to go to MIT. And I'd gotten accepted to a few places, but I went to MIT because, in all honesty, it was the best place for me as a burgeoning engineer, but it also gave me the most options. And then I actually started doing an internship while I was there. I was working in the material science department as a freshman, doing some research with some folks who were working on superconductors. And I got an opportunity to intern at JPL. My advisor, freshman advisor, arranged it. So I started spending the summers and doing research. I did my master's thesis out at JPL. And then MIT said, well, we'll let you stay for a PhD, a doctoral degree. And I was like, hey, that gives me more options. And then when I finished my doctoral degree, the dean at the time said, hey, we're going to hire you on the faculty. Well, MIT made a mistake a third time of making me stay. So I wanted to become a faculty. And they said, well, you have the option of going on working at Boeing and working them. And my work on with Boeing led to so many other things because it gave me more options. And then after that, and I will tell you, then I said, even the decision to stay at MIT was all about options. I had 6 job offers and I was choosing between them. And they said, we'd like you to stay as a faculty member. And I basically said, hey, I'll take that because that gives me more options. Then I moved to Georgia Tech. And then I started commuting back and forth to Cayman every weekend to sing and to see my wife, of course, and my kids. And then I moved then to Austin. I still do that. But in every step of the way, I basically took options. Take a fork in the road, take the one with the most options. And finally, if you want to leave a mark in this world, take on a grand challenge. And one of the biggest challenges I took on was to come up with a research agenda to chair the committee for coming up with a research agenda in autonomy research for civil aviation. I was not at the time an expert in autonomy, but I took on a challenge and it led to really great things, including this picture of me testifying before Congress about urban air mobility a few years ago. And so with that, I'm going to stop and entertain any questions that you might have.
Yeah. Thank you, Prof. It's quite a lot. That is. Do we have any questions for the Prof at this time?
Yes. John-Paul, a question about the hydrogen plane. Would it be under a branded airline or is it a new airline you would want to start? How you plan to?
Yeah, good question. So we would not. We actually, to be honest, don't even want to be in the business of producing airplanes. We just want to be in the business of actually selling hydrogen because that's where the money is. However, if you think about the, everybody's seen the Nespresso capsules that people use at the home for coffee, Nespresso, the ones that you put in there and the thing. Nespresso had to build their first coffee maker to standardize and get people accustomed to actually using those capsules. So that was one of the things that when we talked about the modular thing, we thought about, we could make the best modular storage system. Literally, we fill those things at the wind farm or wherever, at the hydroelectric plant. We transport them, we put them in the airplanes like batteries. And the issue is, how do we guarantee and control our destiny that somebody will make an airplane and a powertrain that could use our hydrogen? So that's the reason why we decided to build an airplane, because we basically said we want to make sure we catalyze the market because we want to sell hydrogen because that's where the money is. But the thing about it, in our airplane, we've actually, that Toyota makes a Mirai, which is the hydrogen powered car. The way hydrogen car works is that it actually uses the battery to run the car and it uses the fuel cell. Everybody know that a fuel cell is basically an electrochemical reaction that takes hydrogen and oxygen and turns it into water and then electricity. So the Mirai takes the hydrogen and the oxygen from the air, combines them, make water and electricity, and then that resupplies the battery. But the battery serves as the primary source for propulsion of the vehicle, the motors. And it serves as a buffer because fuel cells have traditionally been very hard for you to control the power as finely as you can. Our powertrain, the one that you can go take a look at the patent, has no batteries. So we figured out the AMA controls and optimizers. So we figured out how to design the system that you don't need batteries, because that's the only way you could get the weight case to close, to put on an airplane, because airplanes have to be as light as possible. So the idea for us is to be not really an airplane producer, not even a powertrain producer. We're actually going to sell those kits at pretty much cost to airlines, existing airlines. So we now have over 200 orders, letters of intent, which are like initial orders from different airlines. So like Raven, Alaska, folks in Iceland, we've having conversations with folks all over the world around there. We have a contract with Connect Airlines, new startup out of the Northeast, US, to basically do 75 hydrogen powertrains and modify the airplanes that they'll buy for that. So we're talking to airlines across the world about this. And we, like I said, we have 200 plus letters of intent. I think that number will increase significantly once we get our first flight in. Fingers crossed by the end of the year, certainly in January of next year, the latest. But the answer to your question is, we're not into the airplane production nor the airline operations, but we're really into designing the powertrain so that we know it closes the case, modifying the aircraft. But in the end, we're about selling the hydrogen, selling the fuel, because look around you. Which companies always come out on the top side when it comes to economics? Is the energy distributors and the energy producers. So that's where our thing is. So we're not competing with any Pratt and Whitney or any or Rolls Royce, anything. We're competing with Esso and Texaco and Shell. That's really our ultimate competitors are.
Thank you.
President Junior, I have a question.
Yes, sure.
Dr. Clarke, I just thought that your experience is so wide-ranging and it's so dramatic in terms of the flow of movement of aircraft, etc. You mentioned that you are presenting before Congress on autonomy.
Yeah.
I take it as for autonomous aircraft as distinct from autonomous vehicles.
Yes, autonomous aircraft. Yes. In fact, I have a student. I have a couple of students. One of my PhD students from Georgia Tech, who's finishing up, is defending next week Monday an autonomous decision making for missed approaches, and I have a student at UT Austin looking at autonomous conflict resolution for basically UAMs in the urban environment. So yes, I love autonomy. Sorry, I digress.
Yeah. So the question that I really want to ask is that for long flights, I see it being discussed that they plan to reduce the number of crew in the aircraft and maybe get the crew down to one person who would be in charge of an aircraft maybe as large as a 380, an A380, transporting people on a 10, 12-hour flight. And the question, of course, is when would that crewman rest and then begin to fly again? And would an autonomous aircraft in such a case be sufficiently, what would I say, inspire sufficient confidence in those passengers that they would sit in that autonomous aircraft and allow it to transport them like that? And this is against the background that we know that SpaceX and Elon Musk has had autonomous spacecraft carry up non-astronauts for an entire weekend, for an entire weekend, and the only thing they complained about was the toilet needed a little attention. But for the common person who is not necessarily aviation inclined, isn't that a hurdle that we would have to cross over to inspire confidence that they don't need to be an expert in aviation to feel safe in such a vehicle.
Right. So let me start with the first part of your question about the 380 and long haul flights. So currently, because of crew rest requirements, any flight over 8 hours requires 3 crew, and for longer, even 4 crew, even though there are only 2 crew in the cockpit at any moment in time. And so, to my mind, the first thing of autonomy will allow us to get rid of the additional crew because, right, if you think about situations, and now that you have the crew rest integrated in the cockpit where you don't have to go outside, you can have, usually you have to come. The problem when you have crew rest is that you usually have to leave the cockpit to go and sit down somewhere in the airplane to come back, and then you have to knock on the door, somebody has to let you in. So if there's one person in the cockpit and they're incapacitated, then you have a problem getting in the cockpit. In the like 350 and most of the configurations, the crew rest go right directly into the cockpit, so you don't have to be outside and there's no door issue. So with that said, the big benefit is going to be the fact that one person can be resting and one person can be flying, right? And you can have the autonomy aiding monitoring, and I really mean monitoring, and in some cases overriding, right, the human, because most of the accidents, if you look at them, albeit the case that every time they don't know what it is, they blame human error. And the point is because if you look at the way we certify airplane, whenever we have a problem that we can't deal with through a physical system or a software system, we say, oh, the pilot would handle it. And even if it causes problems and the pilots fail, they basically say, oh, it's the pilot's fault. It's not the pilot's fault because you didn't design the thing to basically keep track of keep within the limits of the cognitive load of the pilot. Anyway, again, back to the point, which is, I think that's going to be the first thing. And so what you'll have is you'll have both pilots for takeoff and landing. That's just standard procedure. But you'll have one pilot flying on the long haul with the monitoring. And I will tell you, I've jump seated many times across the country when I was doing my research. It's boring as crap up there on a long haul flight. And so the fact of the matter is, having an autonomous system monitoring, like when you're driving a car and you're looking at whether you're falling asleep or not and all those things, that's the kind of thing you can do. There's some other things there as well. But I think that's really going to be the benefit. Going from 3 highly paid pilots down to 2 on long haul is really going to where you're going to do the first thing. Now, the question remains, in the longer term, are you going to have one pilot or no pilot? Right? And so the question, there's a great cartoon, right, where you have a pilot and a dog in the cockpit. The pilot to monitor the systems and the dog to bite the pilot if he tries to touch anything, so that they only touch it when they really know that there's an issue, that there's the life and death, right? Because a lot of the accidents are caused by cognitive, dissonance on the part of pilots, and also mode confusion or unexpected modes in the software. And so that's a question for debate. I do say, however, that it's not autonomy as we know it now. Right now, autonomy as we know it is, I'm going to write a software, I'm going to write an algorithm, I'm going to prove that it's going to work in all situations within these limits. And that's not really where you get the benefit from autonomy. You get the benefit from autonomy from autonomous decision-making, right? Which is a learned thing, and it's AI, and that is going to be hard to certify. I don't think any of us will be around by that time when we get that into airplanes, but that is the longer term thing going on. And I will end by one thing, which is Tesla, right? The folks on SpaceX, the guy who did the control system, I know him, really good example of quadratic programming, etc. The Tesla idea that you're going to close a safety case to 10 to the minus 9 with visual systems only on the vehicle is ludicrous. For the following reasons, we have never been able to close a safety case with a single sensor system on a moving vehicle. If you look at how we do landings at Norman Manley or any other major airport, you usually have an ILS system on the ground. You have the ILS system in the airplane. You have trained pilots on the ground. In the air, you have trained technicians, and the system is calibrated periodically. If you have obstacle clearance zones where you can't build. You have whole short lines and procedures. All of those together get you the 10 to the -9, right? It's preposterous in my mind to think that you're going to get to 10 to the -9 using a single sensor system on a moving vehicle. Just not going to be done. And so we have to decide whether it's cost effective to do it or not, but it's just not going to happen that you're going to get to that 1 in a billion, which is the standard that we have in aviation. There's a 1 in a billion chance that you have an incident.
Well, sorry that I don't want to take up too much time, but what you have led us into, we have a problem in Jamaica in terms of our safety and motor car accidents and the high death rate. And the question is this: with significant technical engineering in terms of like what you speak about, could that be used to assist us to reduce significantly the number of crashes that we have, albeit we know that we have a disciplinary problem.
Oh yeah, well you said it. I was going to respond. I was going to say that because my very good friend Janine Dawkins, you know, who, as you know, is I think is she acting PS in the transportation ministry. She did her PhD thesis at Georgia Tech, looking at timing of filter lights and traffic lights for aggressive behavior. I don't. You can ask her where she got the inspiration for that thesis from, but I suspect we all know. And so one of the things that I think, I mean, this is just me, just thinking wild and wacky thoughts, is I believe that ultimately intersections and interactions between cars, you could, as you say, have autonomy overriding people's behavior. And I think that in some societies, that would be beneficial. In others, it might be detracting, but I suspect in ours, it might be beneficial. and that would be a great problem to work on, to do that. But yeah, I do think that's the case. I mean, for example, intersections, let's look, again, I digress again, but intersections, right? It's not the most efficient things to have stop signs, nor is it the most efficient thing to have traffic lights. In the Netherlands, they don't have stop signs at intersections. They have yield signs, right? Because they basically, from a very urgent age in the Netherlands, they train you as you come to an intersection to look around and actually time it so that you go in when people go in. It's almost like a virtual roundabout being created at every intersection, right? And that's part of the culture. Really hard in the Netherlands, if you ever try, because you not only have to look at the cars, you got to look at the cyclists, because there are a ton of them, plus the people who aren't walking. So it's a very interesting skill set to drive in the Netherlands. But, you know, that's something that you could create using autonomous system and sensors around each other. So that's something that we're really cool to explore in the Jamaican context for sure.
Yeah.
Okay, thank you very much, Doctor.
Can I ask one question? Well, one question and one suggestion. All right. Two-part question for you, Doc. One, we know that CRA is involved in getting fuel cells down, and you guys use platinum, I'm assuming, as your catalyst. Catalyst goes bad after how much cost? What's the reuse of your mechanism that you use?
Yeah, the MEA.
Yeah, the NEA.
Yeah, the MEA. We you know, we're working with Plug Power. They're an investor, and they're building our fuel cells. And so the design spec is a 10,000 hour replacement.
10,000 hours. All right, that's pretty good. Last question. So no,
they
there's
signed
no
up for it. So I'm just going to count on them to deliver.
Well, that's excellent actually. That if they can deliver 10,000 hours, that will make you about 4 times more efficient than battery, and comparable to actual fuel. Well, let's see what works out. Next thing, there's research going on now about replacing platinum. You think, seeing that you are very innovative, you think that would be something that you'd look into?
Well, we're actually not using platinum. We're using actually, we're using platinum. We're also looking at titanium too, right?
But titanium is not as efficient as platinum in terms of.
Yeah, but it's also light. Remember, we also have a weight issue.
Light. What you do with your runoff oxygen? What you do with that? Because that's an avenue to make more money.
Yes. Well, you know, we could always use it. I mean, the bigger issue with us is what we're doing to that water, you know, because we could actually use it as potable water. One of the cool things that we designed to our airplane is that we actually have a way to store the water in the wings if you're in turbulence, to stiffen the wing to increase the moment of inertia. And then we have a way to weep the water out over time to help in basically a potential attachment to the boundary layer. So we have some cool stuff, have some fun stuff for figuring it, but the water
when
is
you go high up, where you go high up, you can form ice crystals. Won't that be a problem for you?
well, now for the regional turboprop, not really, because we're just at 25,000 feet, so we're not in the regime where you have too much ice formation on a regular flight, and contrails are not a big issue. Contrails become an issue at higher altitude, so that's one of the things that we have to work on.
To you. That was my next question to you concerning contrails.
Yeah, no. So what, you know, I do air traffic control as well. So one of the things we'll have to do is to basically do, you know, trajectory adoption. You know, detection of supersaturated regions and basically changing your flight path. So there's other best to deal with that, and that's the trade-off, right? You know, if you look at the IPCC report, there's radiative forcing from contrails, but the uncertainty bands is higher, but the uncertainty bands are quite large. So one of the things is, how do you trade off CO2 generation versus contrail formation? And that's something that you can do with this, is that you can get rid of the CO2 and you can manage the contrail formation through trajectory optimization.
All right, thank you very much. You have educated me a lot tonight.
Okay. Is there anyone who has a burning question? Because we're gonna have to wrap shortly.
I have a question. Early on, you was talking about the descending of the plane going down, and you put the plane in idle, right? I use flight simulator. Been using that for quite a few times. But when you put the plane in idle, you really reduce the speed, right? But when you reduce the speed and going down, and you reduce it too much, you can come into a stall.
No, well, actually, that's not true. So
no.
So here is the thing. So in an airplane, and I'll give you the example of the flight management system. There's a mode called FLCH, the flitch mode, which is the flight level change mode. And the way we do flight level change is, you want to go to a lower altitude or a high altitude. And the way we do that is called that speed and pitch. So if you're descending, if you're going up, you basically go to maximum continuous thrust, and you pitch up, and you use your pitch to control your speed. So you don't necessarily slow. And if you're descending, you go to idle, and you basically use speed and pitch. You maintain, you change your pitch to maintain speed. So you're descending at a constant Mach number, right? Until the point where you basically start, as you descend at a constant Mach number, your true airspeed goes up. And then you basically then reach to your maximum allowed true airspeed, or indicated airspeed, in which case, because at that point there, well, it was true because we calculated true. And then you'll hold that during the descent. So what all it means to going to idle will lower your speed if you're trying to maintain the same altitude. But if you're descending, you can control your pitch to maintain the speed.
Yeah. You can normally I use a pitch to maintain the speed to control the speed.
Yes, so like I said, but if you're in level flight, you have to actually use both, right? And that is a different mode. That is basically altitude capture mode. Sorry, I'm going to digress. I've programmed 2 flight management computer systems in my life. So you basically you switch from the flitch mode, or you could do you switch from the flight level change or the vertical speed mode to the altitude hold mode. And that basically changes the thrust and the pitch together to keep you at a constant altitude. But if you're going to change altitude, it's usually either speed and pitch, right? Or you do a vertical speed where you basically, and that's where you get into trouble. Because if you go into a constant vertical speed and you basically have to a higher vertical speed and you run out of thrust authority, then you're going to
Then you're going to stop. Okay, yeah, all right, yeah.
Okay.
Understand. Yeah.
Thanks, Stefan.
All right, thanks. All right, thank you.
Is that the last question? Sounds like it was. Okay, President Junior, maybe I could just introduce the person who's gonna do the You know, I thought of asking the person who is gonna do the thank you, because he also went to Calabar. But then listening to all the full presentation, I realized that he is also a pilot. So it makes my pick even more appropriate. So I want to call on PDT Ralston to do the thank you.
Thank you, President Stewart. President Junior, fellow Kiwanians. John-Paul Clarke. I think your father, Jervis, must have known you would be that type of person where he gave you so many names. You started off by saying that you don't like to speak a lot, but then you qualified about yourself, but then you went on to some subjects and you really got passionate, and we could see the level of knowledge that was coming out of you. And I know some of us got lost when you get to linear and quadratic stuff, but we tried, and we tried to follow along with you. Professor John, while undoubtedly you are a very busy person, the fact that you have graced us with your presence this evening and have come to tell us of your exploits is something that we thoroughly appreciate, and we really give thanks for you for coming here this evening. You know, there are many of our sons and daughters of this nation that has made us proud, and you are undoubtedly among one of those. You give the utmost for the highest, and that you learned when you went to Calabar High School. A privilege that some of my Kiwanians brother would envy you for, but I would not, because myself and Stuart went to Calabar also. You know, you're a very colorful person, much like your father, Jervis, who was a Kingston Cricket Club manager, a very, very loved member of the club. And I want to say that when I hear all the things that you have done, I think that, you know, it's more than one person, and you look like a big person based on your picture. And you throw shot put and discuss and all them things. So it kind of come together, you know. But one thing I wanted was to maybe ask you a question, because you're into space and all of that stuff. Garbage in space, is that a major problem? You going to answer me after I finish the thank you, but it's something that I think about all the while.
Yeah.
I know a lot about what you have said about the ATR 42 and the Dash 8 turboprops. And, you know, so it kind of grabbed me there. I spent quite a bit of my life manipulating some of those aircrafts. But today has been a very great time spent with you. I have tried to grasp as much as possible. Not all, but I'm sure that I will continue to look at what you have said, because I have the meeting recorded, so that I can look at it at a later date. I hope that today, what seems to be a recurring thing in your presentation, I hope that today you had fun, because you seem to do everything to have fun.
Yeah, well, if it's not fun, don't do it. That's my rule.
Yes. You know, but on behalf of the Kiwanis Club of Kingston, and indeed all the Kiwanians and guests gathered on this platform who would have gotten something out of your presentation, we just really want to express our appreciation and to provide you with some memento of that time you have spent with us by presenting you with a certificate of that appreciation. We hope that it will find some place a man of you know, you might have to have a museum to put honors and recognition. And all.
Yeah, my office walls are pretty bare. I have
Yeah,
mine.
yeah, but it was good. It was enjoyable. I know a lot of people would have enjoyed it. And by the way, when you're in Cayman, one of our guest speaker lives there, Michael Holden.
Yeah, I know Michael. I know Michael. He's here. So
yes.
Yeah, man. But thank you again. And maybe you could just quickly. I don't know if you can do things quickly, but rubbish in space.
Oh no, that's an easy answer. You know, very small specks in space. Remember, you're moving at like 7,600 meters per second in low Earth orbit. So any little speck can blow a hole through a spacesuit or through the wall of a space station or a capsule. So that's really a big issue. For one of my colleagues at UT Austin, Mariba Jah, he's a co-founder of Privateer with Steve Wozniak. They track space junk, and they're actually working on systems to actually basically recover them. So it's a big issue because very insignificant things that look small on Earth, moving at 8,000 meters per second, 7,600 meters per second, are dangerous. And so there's a lot of stuff floating around because they disassemble and all that. So
yeah.
Thank you very much, President.
Okay.
Yes. And again, thank you very much, Prof. And I think you'll recognize who I am, don't it?
Yes.
I've been to your home in Cayman several times. Even when you're not there. Even when you're not there.
Yes. Don't worry, we know that.
I just trying to come off.
I was. Eh?
No, I'm just trying to come off the share. Continue.
Yes. I said I was hoping you were in Jamaica so we could go for a drink.
Well, I went to Jamaica on Saturday. I coming for a funeral on Saturday morning.
Yes.
Ryan White's funeral. So coming over Saturday morning. But I'm leaving on Sunday to go to Atlanta. So I'll be around Saturday night.
Saturday night then.
Yeah.
All right. Thank you again. I can't tell you on behalf of the club how much you have enjoyed what you have said. But it just gets me a little scared. I'm hoping that by the time you develop some of these things, I won't be around.
No, don't worry about it. You think, listen, if you get nervous when I get nervous. So I'm not nervous, so don't worry about it.
You're not nervous.
I'm not nervous.
Okay, my son. And thank you again.
Could I just get in one little one? Prof,
yes.
have you ever been approached by the Jamaican government to try to make some kind of contribution to our situation? I mean, is that something that has ever come up on the agenda?
Well, I've had discussions with various folks over the years, and I offer advice when asked, but I haven't really had a formal role or anything like that in anything. But I offer my advice when asked about things. So
okay,
yeah. But I'm happy to serve. I mean, as you can see in Cayman, I'm chairing the board of Cayman Airways. I'm on the Film Commission, and I've served on a lot of things for the U.S. government over the years. So I actually have done a lot of public service. So and I always, like I said, if people ask, as they have over the years, I offer my advice. So
okay, thank you.
Thank you again. I'm sure we can talk some more after the meeting, Prof. But
yep,
I'm going to call, and I hoping that Stuart is a very good DJ, so you can listen to him and see after the meeting and see if you can use him.
He doesn't run the radio station anymore.
Yeah, you don't do the radio station anymore. All right. No, Sarge, where are you? You're still around? Chairman Zuri, the real Sarge.
Unfortunately, Chairman Zuri is not present. He had another engagement.
Yes.
And he completely forgot. So I would suggest you do a blanket fine.
Oh, you do the fine then, really? For the Kiwanians, in the absence of our Sergeant Arms, I suggest we do it. A blanket fine, all those present. Levy a fine of $200. I've noted all the names of those present. Thank you. Thank you.
All those members present.
Members all present. Those members present, yes.
Right.
You want to start We'll move to notices and announcements and interclub opportunities at this point. You again,
Thank
Dave.
you.
Thank you again, President Junior. Yes. Before I go into the notice announcement, just let me just ask members to note 2 dates, important dates for next year. ECNC District Convention. Those who want to make arrangements to go to District Convention in Quebec City next year. It's from May the 18th to the 20th. And the Kiwanis International Convention being held in Indianapolis is from July the 20th to 23, 2023. Now, near to home, fellow Kiwanians, we have the most important fundraising project on December 3 at the Jamaica Pegasus Hotel, and I'm referring to our annual Grand Christmas Charity Ball. I hope that all of us are present on the call, have purchased tickets, or if you're unavailable, at least make a contribution towards number of things like the wine, etc. And if you can put up ad, even a quarter page ad in our program, we would be happy. Having said that, tomorrow evening at 5:30, Past President Victor McFarlane will be hosting a meeting of the Christmas Ball Planning Committee at my house. Those of you who may want to attend outside the committee, you're welcome to attend. It's at 52 Haney Crescent. That's on Haney Road, down the road from DHL. Yes. But fellow Kiwanis, please, we want to make this Christmas ball a big success. If we don't get the cooperation, if we don't accept the tickets, then naturally we have to still pay the expenses out of nothing. All right, in respect to interclubbing opportunities, tomorrow evening at 6 o'clock, I may be corrected, I think it's 6 o'clock. Michael Circle K weekly meeting. They hadn't met for 2 weeks because of internal situation. There will be a presentation by Lieutenant Governor-elect Desmond Batchelor on parliamentary procedures. Those of you who can attend that meeting, I will send out the link tomorrow. And I'm going to extend a special invitation to our key clubbers on this call because it should be a very interesting presentation on parliamentary procedures.
At the time, please.
6 o'clock.
Thank you.
6 o'clock. President Malik, I'll send out the link to the presidents, our key club presidents tomorrow that wish to join. And I'm sure that LGE Desmond Batchelor will appreciate your presence. President Junior, that's all for now. Thank you. Yes, are there any more announcements or notices that anyone would like to put forward very quickly? No, then we'll move to the thought for the week. DP Stewart.
You know, I'm gonna have to apologize for today because I was so engrossed listening to Professor John that I lost my marker. I had a marker where I was going to, you know, give you the thought, and it somehow came out, and I can't figure where it was. So I'm gonna have to skip it this week, President Junior. So my apologies, but I just can't find it right now.
No one charge you for that. You have been good.
DP Stewart.
Yes.
I missed I missed the talk by Professor Clarke. But
You
you know,
really do.
but you know, I'm gonna see the tape. But I heard him talking about autonomous planes and vehicles and all of that. And I see a thought here that may be apt. It says, "Hope for the best, prepare for the worst, and expect nothing."
Hope for the best, prepare for the worst, and expect nothing.
I think his expectations are a little higher though.
Much, I know it's much higher.
Much higher.
Okay.
The utmost. All right. Thank you, P, for that thought of the week. We'll still accept it. Are there any other business that we want to discuss very quickly?